When testing ground fault circuit interrupter or GFCI protection for a Whirlpool, several factors can influence the accuracy of your results. If your tester indicates no protection, but the homeowner manually trips a GFCI receptacle and the Whirlpool motor shuts off, here are some possible explanations. Firstly, the tester itself could be faulty. Even if you previously confirmed its functionality, internal issues might cause it to provide inaccurate readings. Secondly, the GFCI receptacle's trip button might be malfunctioning. It's possible that the button requires manual activation to initiate a trip, indicating a potential defect within the receptacle. Thirdly, electrical interference from other devices could be affecting your tester. Electromagnetic interference can sometimes lead to inaccurate results. Fourthly, improper testing procedures could be the culprit. Testing only the top sockets of a receptacle might not be sufficient, especially if the Whirlpool uses a dedicated circuit that relies on both sockets for complete GFCI protection. Fifthly, disconnected wiring within the receptacle or its wiring could be preventing the tester from detecting the GFCI protection correctly. A loose wire could interrupt the circuit and lead to false negatives. To ensure reliable GFCI testing, follow these best practices. 1. Always perform tests with the tester plugged into both the top and bottom sockets of the receptacle. This ensures that you're testing the entire circuit. 2. Manually activate the trip button on the GFCI receptacle to confirm that it is functioning correctly. This step verifies the receptacle's ability to interrupt the circuit in response to a ground fault. 3. Test GFCIs for all equipment, including Whirlpools, that are required by code to be protected. These requirements are in place to ensure safety and prevent electrical shocks. 4. Consider using a dedicated GFCI tester to enhance accuracy and reliability. Dedicated testers are designed specifically for GFCI testing and may provide more precise results than standard electrical testers. 5. If the tester results are inconsistent or questionable, consult with a qualified electrician for further testing and troubleshooting. A professional electrician can identify and address any underlying electrical issues. To elaborate further, let's delve into each of these points with more detail. Starting with the possibility of a faulty tester, it's crucial to understand that electrical testers, like any electronic device, can experience malfunctions over time. Internal components may degrade, leading to inaccurate readings. Therefore, it's always a good practice to periodically check your tester against a known, functioning GFCI receptacle to verify its accuracy. If you suspect your tester is faulty, consider having it professionally calibrated or replacing it altogether. Regarding the trip button issue, a malfunctioning trip button on a GFCI receptacle can be deceptive. While the receptacle may appear to be functioning normally, the trip button may require excessive force or multiple attempts to activate, or it may not activate at all. This could indicate a problem with the internal mechanism of the receptacle, which could compromise its ability to provide adequate GFCI protection. If you encounter a trip button that seems unresponsive, it's essential to replace the receptacle promptly. Electrical interference can also play a role in inaccurate GFCI testing. Electromagnetic interference, or EMI, can be generated by various sources, including nearby electronic devices, radio transmitters, and even power lines. This interference can disrupt the operation of your GFCI tester, leading to false readings. To minimize the effects of EMI, try testing GFCIs in an environment free from potential sources of interference. Additionally, using a high-quality GFCI tester with built-in EMI shielding can help improve accuracy. Improper testing techniques can also contribute to inaccurate results. As mentioned earlier, it's crucial to test both the top and bottom sockets of a GFCI receptacle to ensure that you're testing the entire circuit. Some GFCI receptacles are wired in such a way that only one socket is protected, so testing only one socket may not provide a complete picture of the GFCI protection. Additionally, make sure that your tester is properly grounded during testing. An improper ground connection can lead to inaccurate readings. Disconnected wiring is another potential cause of inaccurate GFCI testing. A loose or disconnected wire within the receptacle or its wiring can interrupt the flow of current and prevent the tester from detecting the GFCI protection correctly. This could be due to corrosion, loose connections, or physical damage to the wiring. It's essential to inspect the wiring of the receptacle carefully for any signs of damage or loose connections. If you find any issues, consult with a qualified electrician to make the necessary repairs. Best practices for GFCI testing are essential to ensure accurate and reliable results. Always perform tests with the tester plugged into both the top and bottom sockets of the receptacle to test the entire circuit. Manually activate the trip button on the GFCI receptacle to verify that it is functioning correctly. Test GFCIs for all equipment that is required by code to be protected, including Whirlpools. Consider using a dedicated GFCI tester to enhance accuracy and reliability. If the tester results are inconsistent or questionable, consult with a qualified electrician for further testing and troubleshooting. Furthermore, let's consider the specific context of testing GFCI protection for a whirlpool. Whirlpools, due to their proximity to water and electrical components, pose a significant risk of electrical shock. For this reason, electrical codes typically require GFCI protection for all circuits that supply power to whirlpools. When testing GFCI protection for a whirlpool, it's essential to consider the specific wiring configuration of the whirlpool circuit. Some whirlpools may use a dedicated circuit with a single GFCI receptacle, while others may be wired with multiple receptacles or with the GFCI protection located at the circuit breaker panel. Regardless of the wiring configuration, it's crucial to test all components of the circuit to ensure that the GFCI protection is functioning correctly. If you encounter any difficulties or inconsistencies during GFCI testing for a whirlpool, it's always best to consult with a qualified electrician. A professional electrician has the knowledge, skills, and equipment necessary to diagnose and repair any electrical issues safely and effectively. In summary, accurate GFCI testing requires a combination of proper technique, reliable equipment, and a thorough understanding of electrical principles. By following the best practices outlined above and consulting with a qualified electrician when necessary, you can ensure that GFCI protection is functioning correctly and that electrical safety is maintained. Let's consider the types of GFCI testers that are available. There are primarily two types of GFCI testers: receptacle testers and circuit breaker testers. Receptacle testers are small handheld devices that plug directly into a GFCI receptacle. They typically have a button that simulates a ground fault, allowing you to test the GFCI protection. Circuit breaker testers, on the other hand, are designed to test the GFCI protection at the circuit breaker panel. They typically consist of a handheld unit and a clamp that attaches to the circuit breaker. Circuit breaker testers can provide more comprehensive testing than receptacle testers, as they can test the entire circuit, including the wiring between the circuit breaker and the receptacle. When choosing a GFCI tester, it's important to consider your specific needs and budget. Receptacle testers are generally less expensive and easier to use than circuit breaker testers, but they may not provide as comprehensive testing. Circuit breaker testers are more expensive and require more technical knowledge to use, but they can provide more accurate and reliable results. Regardless of which type of GFCI tester you choose, it's important to read the manufacturer's instructions carefully before using it. This will ensure that you are using the tester correctly and that you are interpreting the results accurately. Let's talk about the importance of GFCI protection. GFCI protection is designed to protect people from electrical shock by detecting ground faults. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. GFCIs work by monitoring the current flowing through a circuit. If the current flowing into the circuit differs from the current flowing out by more than a small amount, the GFCI will trip, cutting off the power to the circuit. GFCIs can trip in as little as 0.3 seconds, which is fast enough to prevent serious injury or death. GFCI protection is required by electrical codes in many locations, particularly in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor areas. It's important to note that GFCI protection is not a substitute for proper electrical safety practices. Always follow safe electrical procedures when working with electricity, and never overload electrical circuits. Let's also discuss some common misconceptions about GFCI protection. One common misconception is that GFCIs protect against all types of electrical shock. In reality, GFCIs only protect against ground faults. They do not protect against shocks that occur when a person comes into contact with two energized conductors, such as touching both wires of a lamp cord. Another misconception is that GFCIs eliminate the need for grounding. While GFCIs provide significant protection against electrical shock, they do not eliminate the need for proper grounding. Grounding provides a path for fault current to flow back to the electrical panel, which can help to prevent electrical shock and damage to electrical equipment. It is important to emphasize that electrical work can be dangerous, and it's always recommended to consult with a qualified electrician for any electrical repairs or installations. Working with electricity without proper training and knowledge can lead to serious injury or death. A qualified electrician has the expertise to perform electrical work safely and in compliance with electrical codes. They can also diagnose and repair any electrical problems that you may encounter. While this information can be helpful in understanding GFCI protection and troubleshooting potential issues, it's not a substitute for professional electrical advice. Always prioritize safety and seek the assistance of a qualified electrician when necessary. Remember to always turn off the power to a circuit before working on it. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Avoid working in wet or damp conditions. And never attempt to repair electrical equipment that you are not qualified to work on. By following these safety precautions, you can minimize the risk of electrical shock and ensure that electrical work is performed safely. Furthermore, consider the age of the GFCI receptacles. Over time, GFCI receptacles can degrade and become less reliable. If your GFCI receptacles are more than a few years old, it may be a good idea to replace them, even if they appear to be functioning correctly. New GFCI receptacles are relatively inexpensive and easy to install, and they can provide an added layer of protection against electrical shock. When replacing GFCI receptacles, be sure to follow the manufacturer's instructions carefully, and always turn off the power to the circuit before working on it. It's also important to choose the right type of GFCI receptacle for your application. There are several different types of GFCI receptacles available, each designed for specific uses. For example, there are weather-resistant GFCI receptacles for outdoor use and tamper-resistant GFCI receptacles for use in homes with children. Be sure to choose a GFCI receptacle that is appropriate for the environment in which it will be installed. Another factor to consider is the amperage rating of the GFCI receptacle. GFCI receptacles are typically rated for 15 amps or 20 amps. Be sure to choose a GFCI receptacle that is rated for the amperage of the circuit in which it will be installed. Using a GFCI receptacle that is not rated for the correct amperage can overload the circuit and create a fire hazard. In addition to replacing GFCI receptacles, it's also important to inspect the wiring of the circuit regularly. Look for any signs of damage, such as frayed wires or loose connections. If you find any damaged wiring, have it repaired by a qualified electrician. Damaged wiring can create a fire hazard and increase the risk of electrical shock. Finally, consider the location of the GFCI protection. In some cases, it may be more convenient or effective to install a GFCI circuit breaker in the electrical panel rather than using GFCI receptacles. GFCI circuit breakers provide the same level of protection as GFCI receptacles, but they protect the entire circuit rather than just a single outlet. GFCI circuit breakers are particularly useful for protecting circuits that supply power to multiple outlets or appliances. When installing a GFCI circuit breaker, be sure to follow the manufacturer's instructions carefully, and always turn off the power to the circuit before working on it. By taking these steps, you can ensure that your GFCI protection is functioning correctly and that your home is safe from electrical shock. Let's discuss some advanced troubleshooting techniques for GFCI circuits. If you are experiencing problems with the GFCI circuit, there are several things you can do to troubleshoot the issue. Firstly, try resetting the GFCI receptacle or circuit breaker. Sometimes a GFCI will trip due to a temporary surge or spike in the electrical system. Resetting the GFCI may restore power to the circuit. Secondly, check for any obvious signs of damage to the GFCI receptacle or circuit breaker. Look for cracks, burns, or other signs of physical damage. If you find any damage, replace the GFCI receptacle or circuit breaker. Thirdly, try unplugging all appliances and devices from the circuit. Sometimes a faulty appliance or device can cause a GFCI to trip. Unplugging all appliances and devices may help to isolate the problem. Fourthly, use a multimeter to test the voltage and current on the circuit. This can help you to identify any electrical problems, such as a short circuit or a ground fault. Fifthly, if you suspect that there is a ground fault, use a ground fault locator to pinpoint the location of the fault. Ground fault locators are specialized devices that can detect the presence of ground faults in electrical circuits. Sixthly, if you are unable to troubleshoot the problem yourself, consult with a qualified electrician. A qualified electrician has the expertise to diagnose and repair any electrical problems safely and effectively. Remember that electrical work can be dangerous, and it's always recommended to consult with a qualified electrician for any electrical repairs or installations. Working with electricity without proper training and knowledge can lead to serious injury or death. By following these advanced troubleshooting techniques and seeking the assistance of a qualified electrician when necessary, you can resolve problems with GFCI circuits and ensure that your home is safe from electrical shock. It's also important to remember that GFCI protection is not a substitute for regular electrical maintenance. Have your electrical system inspected by a qualified electrician on a regular basis to ensure that it is in good working condition. Regular electrical maintenance can help to prevent electrical problems and ensure the safety of your home and family. In addition to GFCI protection, there are other electrical safety devices that can help to protect your home and family. These devices include arc fault circuit interrupters, RFCIs, and surge protectors. RFCIs are designed to protect against electrical fires caused by arc faults. Arc faults occur when electricity jumps between two conductors, creating heat and potentially igniting nearby materials. RFCIs can detect arc faults and trip the circuit, preventing a fire from starting. Surge protectors are designed to protect against voltage surges. Voltage surges are sudden increases in voltage that can damage electronic equipment. Surge protectors can absorb voltage surges and protect your electronic equipment from damage. Consider installing RFCIs and surge protectors in your home to provide additional protection against electrical hazards. In conclusion, GFCI protection is an essential safety feature that can help to prevent electrical shock. By understanding how GFCI protection works, following best practices for testing GFCI receptacles, and seeking the assistance of a qualified electrician when necessary, you can ensure that your home is safe from electrical shock. Remember to always prioritize safety when working with electricity, and never hesitate to consult with a professional for any electrical repairs or installations.